Hello and welcome to CS264. This is Lecture 6 and this is Lesson 1. In this lesson we're going to look at object-oriented programming fundamentals, and we're going to do this using the C# programming language. In particular, we're interested in considering the different kinds of relationships between classes in C#. So we're interested in the is-a relationships, and that's a generalization or inheritance relationship. We're interested in two types of has-a relationships, and that would be aggregation and composition. And we're interested in using or association relationships. So we're going to see C# examples of all the various relationships as well. So if you're asking yourself, what's the difference between association, aggregation, and composition, then this lesson should help you with that. So there'll be a bit of theory first, and then we move on to some practical things. And I'm going to use and introduce you to some of the UML as we work through the lesson. I'm sure you will have seen some of the UML before. You can see some of it just down here, but we'll take it slowly and work through it. So an association then, that's a generic term that's used in an organization of objects when a class uses members. In other words, it uses the methods and properties that are provided by another class. The organization becomes specifically a composition when a parent class object owns a child class object, and that child class object cannot meaningfully exist without the parent class object. So if the child class object can exist without the parent class object, then the organization is referred to as an aggregation. So we can see all this using the UML as well. So we can visually represent generalization, which is an inheritance, and we can association, composition, and aggregation. And you can see that using these four diagrams here. So we have class A and class B, and we see that class B is an extension of class A, and that's how we represent like a subclass, if you like, an extension. Then we have an association, and it's just a straight line between the two classes. We have composition, that's represented by this filled diamond, and we have aggregation, which is this open diamond. Okay, so these are the standard UML notation that you use for each of these four types of relationship. So we know that there's all kinds of ways to represent inheritance, like that's the extension, and we see that in some of the later lessons. Okay, but I mentioned earlier that aggregation and compositions were two special kinds of association. Okay, and in fact, a composition is a special type of aggregation. So both aggregation and composition are has-a relationships. So the composition can be considered much more restrictive than association, if you like. And with composition, composed objects cannot exist without the other composing object. Okay, that's not the case with aggregation. The existence of a composed object is optional. So with aggregation, the child object can exist beyond the life cycle of the parent, and with composition, the child object cannot exist beyond the life cycle of the parent. So that's the subtle difference between them. Okay, we're first going to look at some associations. So an association then, that is a uses or using association or relationship between two or more objects, where the objects have their own lifetime, there's no owner involved in the relationship, and furthermore, the objects participating in the association can be independently created and destroyed, so there's no dependence there. So navigation across an association is bidirectional in them by default. It's possible to represent limited directionality, of course, by adding an arrowhead pointing to the direction of the traversal. Sometimes you see that, or you add an optional label which can be added to the association. Arrows on both sides of the relationship indicate some bidirectional association. I just leave out the arrows in that particular case myself, It's possible that an object, or which you remember is an instance of some class, participates in an association relationship with another object of the same class. That means that we have this kind of reflexive association. Reflexive association, that's what it's called. Okay, so for example, an employee object may participate in a manages association with another employee object. They're both employee objects, but one employee manages another. So you can see class X here might be the employee, and we see we have this manages relationship here. Okay, and it's called reflexive association. So association in practical terms usually involves some kind of messaging, so you call a member method or you access a property of the controlling object, and so the line in the UML implies that one object can send a message to another object. And objects involved in the association can be thought of having a role with respect to the association. You use roles when an association name is difficult to define. Okay, so roles provide this alternative to the association name or help make the name clearer. Sometimes with association as well, you can represent some multiplicity. So that's a definition of the cardinality. And it tells you about the number of elements, okay, that can participate in a relationship. And we can see that using this table here. You've seen some of these before. Multiplicity of 0, exactly 0, it actually must be empty. That's 0. 0 to 1, no instances, so 1 instance is allowed, 1 to 1, and so forth. And you can work your way through this. And so this is typical multiplicity that you might have here, and you can see this is a directed association because it's got an arrow. It has multiplicity. Here we have an association using multiplicity as well, okay? And here we have another one as well. And you can draw your UML left to right or up and down. I use the plant UML here to do all my drawing for UML within Markdown, and it works very nice for me, and I'd recommend it for sure. Okay. So these are kind of commonly used examples explaining association. So the diagram here shows a professor is the author of a particular book. So the professor wrote that book. You look at the tense on the association name, okay? So when modeling with the UML, you tend to use the grammatical past tense for wrote instead of writes. So you don't say the professor writes this book, okay? She wrote the book, okay? So that's how it works. And there's a style associated with the UML, and it's in a great book by Scott Ambler, and I certainly recommend you have a look. The elements of UML style, or UML 2.0 style. So here's an example of bidirectional association using C#. Okay, we'll have a look at the program now in a few minutes. There's no ownership between the objects, and both objects or classes have their own life cycle, and both can be created of and disposed of independently. So for example, we take a module class, and then we have a student class, and a module may have one or many students associated with it, and a student, on the other hand, may also be taking one or more modules. The piece of code I'm using here is a program called My Association, and we can have a quick look through this. We create a module class, and we have some attributes here, and the module has a list or includes a list of students in here, and it has a name and a code, a constructor, and we have a way to add a student. Okay, and it's called an association then. So we can look at the students who are associated. There's a method here called association. We find all the students that are associated with this module, and we can iterate through them and list them out there. We use a for each to iterate over the list, and that's easy. Similarly, we have a student class, okay, and the student again has a list of modules in here as part of its private members, and we can execute, and we can see the association here. Just allows us to be able to iterate over the list of modules. So we see that the student class or student objects use modules, and the modules use students, and they both can exist independently. At any one point, you might have a student who isn't taking any modules, or you may have a module that doesn't currently have any students. And here I'm creating a new module, 264, creating two students, Jane Doe and Joe Bloggs, and I'm adding students, and I'm just looking at the associations. So it's very straightforward. Actually, we can run this. We can go to the example, and you can find this. We can see here that this program is called My Association. So if you go to the demos and you look at the list of demos, you can see, there's one called My Association. So you can pop in there, you can download and install all of these, and you can just cd My Association, and we just do code dot, just have a look. And it should launch VS Code with this particular example. And here we are. And that's the exact copy of the program. We can run this. And it works as expected, I hope. Yeah, so we see that the students associated with this module, software design, are Jane Doe and Joe Bloggs, which is what we expected because that's the way we set it up. So it's now you could actually start and assign modules to the student and work with this. So I'd recommend you take this program and play with it. It's all about bidirectional associations. And that's the UML for the association. Okay, so now let's move on to the next kind of relationship, and that's the aggregation relationship. Okay, so if you remember from earlier, aggregation is a specialized form of association. In other words, where all the objects have their own life cycle, but there's ownership involved in the association. So with aggregation then, a child object cannot belong to another parent object. Okay, so we could have a school object, for example, here, and we could have a student. We have a student object here, and we could have a student attends a school. Okay, so we would probably decide that a student can only attend one school. Okay, in other words, it might belong to that school. So if they belong to that school, they can't belong to another school. A student could leave that school, however, and belong to another school later. So that object each has their own life cycle, so it's fine. So we have this again, attends. Look at the tense in this as well. So we could use, as I said previously, we use this transparent or open arrow or open diamond, sorry, to represent this form of association called aggregation. Okay, so it's a containment. You might, for example, see a vehicle contains a wheel, an engine, a door. In fact, and you could add some cardinality here to add how many wheels this vehicle has, how many doors, and how many engines it has. Okay, so we sometimes actually see the model for a vehicle utilizing composition, and we'll discuss this a little bit later, rather than aggregation. I don't agree with this myself, this determination. It means that once the car is destroyed, then all parts are also destroyed. That's what this model tells us here. Okay. In other words, we have, but with this particular one here, and this model, it tells us that once the vehicle is destroyed, the parts can exist. Okay. So I think they may be available for repairs, or something like breaker's yard or something like this, and then you can reuse it. Okay. And then, so I think aggregation is better for this particular model. It depends on the vehicle, of course. You might have a vehicle that doesn't allow you to do this, or just doesn't work that way. Have a look at the example here you might for this vehicle. Okay, so I have an aggregation example, and here we have a class for wheel, door, and engine. We can create wheel, door, and engines. We can create a vehicle. An engine has the vehicle has an engine. It has 4 wheels and 4 doors in this particular case here. So I'm creating this association. So this is the aggregation. I have constructor here that tells me what the model is, and now I'm actually have this helper class that allows me to instantiate different kinds of arrays of different types. So that's what this method that's called here. So it allows me to create an array of wheels, an array of doors, of whatever, and it's just kind of handy way to do it, and it's worthwhile looking at it, and it's something you can see a little bit later yourself. Okay, so I create my program. So I have a vehicle here called the Tesla Model S. So it tells me that I've created this, and it works just fine. So this is aggregation. Okay, that's not too bad. Okay, we could run this again. As I said, let's pop over to our. Let's go back here, and we can see that I have an aggregation as well here, and I can say. My aggregation. I won't do all of these in this lesson. You can go and look at them yourself. I'll just do one more, this one here. Okay, and I'll just run this as well. I'm running it here, so we created a vehicle using aggregation. Okay, so not too bad. Okay, and it's definitely worth working through the software and seeing how it works. Okay. Okay, another association then is composition. Now, composition is a bit more complex, I guess. It tells us and implies that the contained or child class cannot exist independently of the containing class. So that means if the container is destroyed, the child is also destroyed. So, for example, you consider a book class and a page class. The page can't exist without the book. Well, I suppose you could think so. You could think it would. But this is the model. It tells us this because the book is composed of pages. So the book is destroyed, the pages are also destroyed. So there's a strong life cycle dependency between the two classes. Of course, you could rip the page out and do all that kind of stuff, but then you would say, I wonder where this page came from. It belonged to a book. It shouldn't be here. It shouldn't exist independently. So, as well as being described then as a has-a relationship, composition is often described as a part of relationship. So composition, like aggregation, is unidirectional. It's a strong association, unlike aggregation, which is weak. So let's go back to the vehicle example that we looked at in the aggregation section above. Let's assume that the individual components, this time like door, wheel, and engine, cannot exist independently of the vehicle itself. Why? Well, because that's the rule. That's the model we're going to use for this particular software design. And the rules, we as software engineers look at the world, we model it, and then we write software that realizes the model. Two people may look at a scenario and have two different models or two different views. Okay, so it's an important point to note. So it doesn't matter what you think of the design when you're implementing it. If it's the accepted design, you code it so that it meets the specification. So the best time to disagree or contribute to the model is during the model development. So now we're going to have the exact same as we had last time, like saying UML almost, except we have these fields. So we're instead of using aggregation and composition, and that tells us as soon as the vehicle disappears, the wheel, engine, and door objects can't exist independently. Okay, so you'll notice last time when I created these objects independently, like I could create, because they're public wheel class and the public door class, I could create those anywhere and then use them, and I did use them within this vehicle class. But now I'm going to create a class called vehicle, and I'm going to define the classes contained within this. Okay, so it's pretty much the exact same, but as soon as I created the, as soon as I created it, it would be fine, and then when I destroy it, it's destroyed. Okay, so in other words, I can't access doors, wheels, and engines associated with this vehicle outside of the class. Okay. So I guess in summary then, we could, let's actually, I did make a little mistake there because I should have had word composition here. And let's go and correct that because I'll be giving you the code. So let's go back here. Okay, I have composition. So this is the one I'm looking for, my composition. I'm going to see. I'm just going to fix the message here. I'll run this and we should get the message, so it just works just fine. I see an error here actually. Oh no, that's fine. Okay, yeah, using composition. So that's good. Yeah, that's good. Okay, so I'm happy enough with this. It works fine. Okay, so let's go back. So in summary then, okay, we initially talked about the different kinds of relationships, and we looked at inheritance as one, okay, and those are where the is our relationships. So then we moved on to look at the has our relationships. So we were interested in aggregation, composition, and association. Okay, we saw examples of each of them. But the association, if you like, is more broad. Aggregation is specific, and composition is even more specific. So those are how they would relate to each other. I'd recommend looking at these references, okay? The OO portal, Unified Monolithic Language, the UML Notation Guide, UML Best Practice, and UML Drawing Diagrams of Plant UML, which are the ones that I use in this particular lesson. Okay, so that's the end of the first lesson. Thank you very much for watching.